Hi, thanks for tuning in today. Welcome back to the channel. Well, a nice clean workbench. I just minutes ago finished wiping it down and put away the engine that was on there. Next is a 582 that was shipped in that's been idle for a long time and needs an inspection. So let me show you how the engine was packaged up as it arrived. Here is said engine. It came in on this skid. It's all nicely strapped down, so it wasn't going to go anywhere. It's on my hoist that I use in the shop, and it's been moved around a few times. I'm glad that I'm going to be taking it apart today because everywhere I park it, it pees on the floor. Let's get this engine unstrapped and get it prepped to go on the bench. Houston, we have separation. Now I've completely photographed this engine all the way around, everything that I can possibly see on it, because there's some things that I want to make sure go back the same way, like where is the wire harness that plugs into the airframe. Here's some primer lines. Where do they go? What's the routing for those? Cooling system, how was it all routed? It's non-standard items as far as Rotax goes, so we need to know where they go. I want this to go back. Same with the engine plates. Everything I need to know, where did it come from, so I can put it back exactly so it fits the airplane again. This engine came with the propeller still attached to it. The bolts were extremely rusted, and one of them actually broke off inside the flange of the gearbox. So that's another project yet to do. So this spacer hasn't come off yet, even though there's a little gap in there. It has to come completely off, then I have to remove the broken bolt out of there. While I'm on the topic of seized up things, this exhaust bracket, this bolt came out with no problem. This one won't turn. It's a little hard, it's a little difficult to see there, but this washer is just moving in there. So this bolt is not even tight, but it's so seized up in the hole that it's threaded into that I can't get it in. So here we go. I'm gonna have to heat that up and do battle with it to get that off. So these nuts here, they're probably put on with Loctite red, or they should have been, which is evident by the fact that my little gun won't undo them. So what do? Well, with Loctite products, or Loctite red in this case, I'm just going to heat the nut up a little bit. Just a propane torch, as you can see. You don't have to get it glowing or anything, you just have to get the temperature up enough to melt, as I describe it, the Loctite product. And now I expect it to come right off. Look at that. Easy peasy. So now, as you can see, it's stripped down enough that it's going to go on the bench. It's a good thing this is a special table where all of the liquids go into a tray underneath. Now, while the gearbox is still affixed to the engine, this has a broken bolt in that hole, and I can't get the adapter off. I've warmed it up previously, and of course I've soaked it with lots of penetrant. So you may want to put a screwdriver in here and beat it until it comes off, but you don't want to do that because you're going to mark it up. So here is a nylon wedge. So this is a much more civilized tool to use on this. As you can see, the wedge will sacrifice itself before it does anything else. And it is starting to move, which is great. So we'll just be patient with this now, and hopefully we'll get this off the rest of the way. And it'll help me with the dead blow. Nope, it isn't doing anything. Let's open it up in a piece and put a nice new shiny finish on this. So I'm just going to stay right here where the bolt is. Alright, go back. Let's go this way. Alright, it's starting to move a little bit crooked on there now, so I better go to the other side. Try and straighten it out. So it comes off straighter. There we go. Oh, I think we got some good action there now. apparently this airplane sat outside for a while. I would not disagree with that at all. All right. Ho-ho! Winner, winner! All right, so there's our broken bolt right there. So we'll have to get that out. But at least we can get access to it now. And just a tick of rust on the back here, but the face isn't damaged at all, and that's what I'm after. So that's why you just got to be patient and spend the time it takes to get these things apart. These are very expensive. You go, oh, it's just a little hunk of aluminum. Nope, lots and lots of money. So we want to save as much as we can, and that means not damaging this. This will clean up just like brand new. Now, thankfully, there's some threads still exposed on this side. So as you can see, I put a nut on there. So what I'm going to do now is I'm going to go get the MIG welder, and I'm going to weld the broken part of the bolt and this face of this nut all together and make it one unit. And then the heat that radiates through the whole thing will make it just come out like it was never even rusted in there. It's pretty amazing. So I've cleaned off the face here a little bit. See, it was nice and shiny. I got vice grips on it. I have my ground clamp on the vice grips because I want to make sure I have a good ground. And then I'm going to get in here around the camera, and I'm going to weld the center of this thing. Don't look, Ethel! It's safe. Welding is over. Okay, so now as I said, this should just come. Look at that. See how easy that is? So pretty simple way, and I go back and forth a little bit, but pretty simple way to get a broken bolt out of a hole. That's from all the years of fixing cars. There's lots of crossover skills. So the broken off bolt has now actually been turned into another bolt, and there it is, came out no problem at all. So in the bucket that goes, and now I'm going to continue on and take the rest of the engine. So this is the E-type gearbox. It's the one that has the starter on it, and the oil is just dripping now into the tray. And what I wanted to show you is the drain plug. I don't know if you're aware, has a magnet in it, and of course it will gather. I've just daubed off the oil, the gear oil that was on it, and you can see the magnet right in the center here, and there's a little bit of fluff on it. It's like really fine, like flour consistency. So I would consider that normal wear, and this has probably never had the oil changed in it, so I'm pretty happy with that. Not too bad at all. So all of the fasteners are removed. Dead blow hammer again. We don't hit this aluminum or anything with a steel hammer. So we're hitting it on the little ears here that are made for that purpose, and it's coming off quite nicely. And there we go. It has come off, and of course sometimes the center of this bearing comes off as well, which is not a big deal. You can just put it back in. If I can get it in the right place, you can just twist it, is what I do with them, and it goes right back in. And of course it won't do it right now because everybody's watching, but I'll do it after. So now let's have a look at the general condition here. I don't see the wear patterns on the gear look perfect. The same here. So yeah, I would say never been serviced. Don't know how many hours are on this engine, but definitely in good shape inside. So again, happy to see that. So I want to keep the gearbox clean and not lose anything. So all of the bolts are bagged up, little sandwich bag. Everything is here. I've sort of partially put the gearbox back together. The rest of the components back here. And we can just close it up. Damage free, stays clean. I'll put a label on it, and it's ready to go back on. So now I can see right into where the rotary valve is. Now the carburetors are off, and uh-oh, there's fluid in here. Oh, but guess what? It's oil. It's not water, and there's some on the PTO side as well. Well, that's interesting. So you say, well, why would there be oil in there? This engine hasn't run for a long, long time. There was a little drip right on top of this is the little brass tube that the oil is actually pumped through to mix with the air and fuel as it goes in, because this is obviously oil injected, has oil pump. So why would there be oil getting into there when the engine has been off for so long? Inside of this fitting right here and this fitting right here, you can see there's a little arrow on it. It's one way, but the whole point is there's a little ball and a spring inside there that won't let the oil run through until there's some pressure applied to it. So this one right here that supplies the mag side, and this one that supplies the PTO side, they both must be leaking. This one substantially more because there's a lot of oil in there. So these are going to get replaced. While we're talking about the oil pump, every single engine that I do, I flow test this oil pump. I want to make sure that it flows the right amount of oil before it goes back onto an engine. As I stated before, I want this engine to go back on and plug in and do all the things that it's supposed to do so it fits the airplane. Well, I see right now a very non-standard wiring hookup on this. Why do I say non-standard? Well, the dual plug with two terminals in it is always the charging leads, which are these two. Now we can identify these as charge leads that go to the voltage regulator because they come out of the magneto. So these are the two AC wires that are normally in this plug. These ones, which I'll make a note of right now, look, they're yellow and black. How do you tell the difference? The easiest way for me to describe it to anybody is these ones are bigger in diameter. So the P leads, or the leads that shut the engine off, are the bigger ones in diameter. These are smaller in diameter. So typically these two P leads go in the 4-terminal plug. Now what else is in the plug? Well, this is a ground wire, the brown one, and this one is gray. This is the tachometer wire. And look at this is, oh, that's been overheated. So do you see this where the wires kind of popped out of there and it's bare? Look at that, it's melted. Let me zoom in on that so you can see it better. So you see how this looks on this side? So this is like when you have a 100-foot extension cord and it gets all windy like a candy cane because it had too much power put through it and it's hot. This is the same idea. There, see the shape of that? So there's our heat right here. So this wire has been making a contact. This one definitely not. Did this charge the battery? Probably not, because we need AC from both of these wires to go to the voltage regulator. So anyway, I'll be replacing, of course, this connector. It'll need the other half of the connector on the airframe replaced because it's going to be melted as well. And I'm going to connect it back in this non-standard manner because, like I said, I take notes, I do pictures mostly because I want this to be able to plug back into the airplane and work properly. And with the P leads and the charge leads reversed, it wouldn't work properly. Okay, so take some notes, put some tape on things if you're going to take connectors apart, label them, things like this. Whatever it takes so that it goes back where it came from. So this hose here looks quite unusual to me. It's hooked onto a fitting right here that leads from the coolant so that if any air forms in the cylinder head, then it is always constantly purged out to the highest point in the system, which is usually a surge tank where the rad cap is. And of course we can see it comes right around here, goes into a fitting here. this is where the bypass hose goes, the inlet to the water pump. So this is a little unusual looking. So I'll have to have a look at the rest of the cooling system on this and try and get my head around how this is supposed to work properly. Right, the great reveal. Let's lift up the head, see what's inside. Well, that looks nice and clean. I expect to see reasonably clean when we're running an oil pump system. And let's put this up. I can see in the cylinder, it looks visually good. I don't see any corrosion in there. I can see a nice looking crosshatch in there still. Now, point of interest, where the intake ports are, when we see these clean spots here, I always consider that to be a really good running engine. And of course we see that on the other cylinder as well. So when this was running, I think it was running pretty darn good. I neglected to turn the camera on when I removed the cylinders. I see a little bit of striations on the side of the piston here, which I think to me would indicate it's probably not running at the right temperature, probably too much. When I look at the ring around where the cylinder head and the cylinder touch together, so this is like keeps the coolant in. When I look at it, I don't know how well it shows, but it's nice and clean on the top. A little bit not so much on the side there. What I'm getting at is we'll look at the cylinder, the PTO cylinder that goes with this piston that has marks on it, and you see how it's kind of shredded off here, or whatever you'd like to call it. Now, why is it like that? It's like that because the cylinder head has been getting big, hot, and then cool, and hot, and cool at quite a rapid rate. I typically see a lot of this on engines that come off of Challengers because they really don't run at the optimum temperature all the time if it's not managed properly by the pilot. But anyway, point of interest here is this. That tells me that I think I need to have a really good look at the way the cooling system is hooked up on this engine and make sure that it's to standard and it cools and circulates properly. So here's the big reveal. Let's split the crankcase and find out if there's any corrosion in this engine. Right, let's lift this off. What do we see? It looks, I don't see any rust and critters, bugs, dirt, water. Looks good to me so far. That's quite impressive. Okay, let me lift the crank out and then we'll have an examination on that. We're still not finished with the inspection on the crankcase. As you can see, the rotary shaft is still in here. We have to remove it. There's this water pump comes off. There's a special tool that fits on the end of the shaft. The crankcase is warmed up so that it releases its grip on the bearing in here. And we tappy and the shaft comes out as an assembly. Then the shaft and all these components that are on the shaft have to be all removed and inspected, and the shaft has to be inspected. So that I will do all of that inspection when I measure everything else for the engine. So now let's carry out a visual inspection on the crankshaft and see what we can see. Well, both of the mag end bearings feel fine. When I look through the window here, I can only see 3 or 4 rollers at this point, but they look like they're not corroded. This bearing here turns fine. That one does as well. Connecting rod again, I can see 3, 4 rollers at the most when I move it that way. PTO bearings. Visually, it looks great, but I can't do what they do on the internet and say, yeah, it just looks fabulous, it's nice and clean, let's put it all back in. No, I actually have to measure this. So I'm going to measure the clearance on the big ends, and then I will put it in my stand with all the dial indicators on it and make sure that it's straight. So that's the next step for this one. Again, I've got to do the examination on the pistons. I can't get the cloth that I cleaned the bench with and go, oh yeah, well that looks great. Oh yeah, that's fantastic. No, that's the way they do it. I've seen it done that way. And no, they need to be measured. Because as I always say, and you've heard me say before, if you don't measure it, you're just guessing. So that brings us up to date on the dismantling of this 582 Model 99. Thanks so much for spending time with me today. I appreciate it. Hopefully you enjoy the video. Please like it, share it with your friends maybe, and subscribe maybe if you feel so inclined. Thanks again. Bye now.